once again to Science Tutorial. This is a program that is designed to help students in the study of sciences. Now, this edition of Science Tutorial is a special edition because it is a revision series for students that are preparing for external exams like WASI, NECO SSCE, and also the UTME, which we soon start. All right. We have been looking at a particular topic in physics, and that's elasticity of material. Elasticity of materials. And so far, we have looked at various aspects of elasticity of materials. So there is need for you to watch the previous video on this topic. We started by defining elasticity. We looked at Hooke's law. We saw the force extension curve, and we generated several expressions that will help us in calculations. And today our interest is on calculations. We just want to use the various expressions that we have generated in carrying out calculations. So we're going to delve into that calculation now. But before that, there is need for us to actually look at some important expressions that will help us in these calculations. Remember to like our Facebook page on Science Tutorial, and also like another Facebook page that is related to this page, that's the Mathematics Meal. And also try as much as possible to subscribe to our YouTube channel that is showing on the screen. And when you do that, you will be spreading the good news of Science Tutorial. All right, quickly before we go to the calculations, so remember all we want to look at today is just calculations. To look at calculation, but before then there are several expressions that we have generated, and it will be very, very important if you watch the previous video so that you see those expressions. But I'm going to list the expressions now, most of the vital expressions that we need for our calculations. We're going to list it so that when we have a question from there, we now know the expression that will be suitable. So let's begin. We know that we obtain an expression from Hooke's law where we say that F is equal to KE. We obtain this where F is the force, K is the force constant, and E is the extension. We extended this expression when we consider the fact that since K is constant for a given material, we can have this. We also say that extension 1 is final length minus original length if original length is represented with L. Remember, in some of your textbook they may use L naught, L sub naught. It's still okay. We are using L, so this L can still be L sub naught as the original length. Now we had another expression that the second extension is L2 minus L. That's the original length. Now we superimpose. We just substituted this here. We arrive at another expression where we say that F1 over L1 minus L0 is equal to F2 over L2 minus L. Okay. Since we're using L, let's use L. So minus L. We have this expression. So you see, this is just, I use this to replace this, and I use this to replace this. Since E1 is equal to this final length minus original length. In the previous video, we actually explained these parameters. Now, F1 is the initial force that produces an initial extension. F2 is the final force that produces another extension. So E1 is that, E2 is that. If you substitute it there, we'll now have this. So it means that in a situation where F2, we are given extension, you know, we can still write this as F1 over L1 minus L is equal to F2 over E2. If in a situation they did not give us the length again, or they wanted us to, they gave us extension, we can still, this and this are the same because this is representing this. So whichever way you decide to write it. But we need to put down the basic ones. Now we also say that it's possible that the expression we are going to use will be in form of what? Of mass. That's the force we are going to use will be in form of mass. And we had expression like W1 weight 1 over E1 is weight 2 over E2. And we can still substitute E1 for L1 minus L and E2 for L2 minus L. We can substitute it there. These are expressions that we arrived at. And we also say that weight is mass times acceleration. So we can have this as M1 over E1, M2 over E2. Now, E1 is L1 minus what? L, which we can still write this as W1 all upon L1 minus L equals W2 L2 minus L. We can still do that for the mass. We have so many expressions, you can just rearrange them. Then we also talked about work done. So that the work done, this W here is work done, not the weight. These ones are weight, this one is the work done. So it's half Fe. We also arrived at work done equals half Ke squared. We also said that work done is half F squared over K. Then we did we arrived at other expressions when we said that the work done is equal to the elastic potential energy and also equal to the kinetic energy in case motion is involved. So we saw that half Fe is equal to half mv squared. We also said that half Fe is mgh. All these are present in our previous video, so there is need for you to watch that video if you are going to actually understand the origin of these expressions very well. So quickly, we are going to take our first question. We're going to take our first question, and then we'll now look for a suitable expression that will help us solve the question. So we'll look at this. So let's pick a question. This question number one. Question 1. This question is 2017 WASI. It's an essay question. It's essay question number 4. 2017 WASI. So let's write the question and see. They say a spiral spring has a length of 14 cm when a force of 4 Newton is hung on it. A force of 6 Newton extends the spring by 4 cm. We say calculate the unstretched length of the spring. Okay. Oh, beautiful. Very beautiful. Okay. 2017 WASI essay question number 4. So how do we go about this? It's a very interesting question. A spiral spring has a length of that 14 cm when a force of 4 Newton is hung on it. So the length became 14 cm when this force was hung on it. Then a force of 6 Newton extends the spring by 4 cm. Calculate the unstretched length of the spring. Now, whenever we want to solve problem in physics, I always like to apply the principle of I see. If you can see, then you can solve problem in physics. If you're a blind man, you cannot. Blindness is not all about having when you don't have the physical eyes. There are people that have the physical eyes, but they cannot see. So I hope you can see. Let's see what I see means in physics. The first I means identify, the idea. The S means settle. Can you see? Then this means explore. And then this means execute. Very simple principle. So whenever you are given a problem to solve, the first thing you do is to identify identify the terms given or the variables or the parameters given in the question. That's the first thing you have to do. Then after the identification of these parameters or the variables, you set it up. Setting it up means using appropriate symbols to represent those quantities. Yes, using appropriate symbols. For example, here they say a spiral spring of length. Of length. Okay, a spiral spring has a length of what? 14 cm when a force of 4 Newton is hung on it. Now, we have parameters. What is this? What it is? Identify what they are. So the moment you know what they are, then you can set it up using the appropriate word, appropriate symbols for them. Then afterwards, you now start exploring. When you have written out the parameters and you now know the unknown, you don't know the quantity you want to calculate, that's the unknown now. You have identified the unknown, then you explore, you start searching for the appropriate expression that you can use, or expressions. Because in some cases, we may not use a single expression to carry out a calculation. We may combine 2 or more expressions in order to carry out a particular word, a calculation. So you explore, you start searching which expression will be suitable. Once you find that suitable expression, then you execute. You just substitute and solve your problem. So that's the principle of IC, and we're going to apply it here now. So let's go together. They say spiral spring has a length of what? Of 14 cm. So the length of the spiral spring is 14 cm. When a force F of 4 Newton is hung on it, then they said again a force of 6 Newton. So I now have 2 different forces. So how will I represent the second force? So this one will now become the initial force. You see that now? That's my L, my F1 now, because I have another force. That means F1 will bring about length what? 1. You see that? Okay. You see why I have to do this? Because I just saw another force, a force of 6 Newton. So I have a second force, F2, extends the spring by this. So extends, talking about extension. The appropriate symbol for extension is 6. So this is E. So this force is 6 Newton. Then the extension, E2, is what now? 4 cm. Okay. Now they say calculate the unstretched length. The unstretched length will be the original length. That's what we are looking for. The unstretched length. Okay, we have F1, we have F2, we have L1, we have E2. We are looking for L, which is the unstretched what? Unstretched length. Unstretched, that's when you have not added any force. When no force has been applied, that's the original length. So how do we go about this? So we now know what we are looking for. What we always form the basis of your calculation is what you are looking for. We are looking for L. So we start moving about to know where L appears. That's what we'll do. Start moving about to know where L appears. So if we look around, there is L here. There's L here. I cannot actually use this expression to find L because I don't know E1. Now there is L here. I know E2, but I don't know what L2. You see that? Becomes a matter. Now I'll come down to this. I know F1 and F2. I know L1. Then L2 minus L is E2. You see that? So in place of L2 minus L, I can use E2 because E2 is L2 minus L. So I can use that. So if I use it, the only unknown will now be this. You see that? The only unknown will now be that. Will now be L. Will be L. So if I write F1 over E1 is equal to F2 over what? E2. Which is this? Which is this expression? I don't know E1, right? But I know L1. So I can actually write this in form of F1 over what? L1 minus what? L equals F2 over what? E2. Beautiful. Beautiful. So I know F1, I know F2, I know E2, I know L1 from here. The only unknown is what? Is L, so which I can actually find by solving. So I have explored. Remember, we identify, we have to set up, and then we have explored. We obtain the suitable expression. How did we do that? We combine two expressions. We combine this and this expression in order to arrive at that. So if we now substitute, what is F1? F1 is 4 Newton. All upon L1 is 14 minus L. F2 is what? 6. All upon E2 is what? 4. Okay? Then if we clear this fraction, we're going to have 6 bracket 14 minus L is equal to 6. 4 times 4. As this times is, that times is. Okay? Now we open the bracket. 6 times 14 will give us 84 minus 6L was 16. Isn't that beautiful? I think it's beautiful. Very beautiful. Very, very beautiful. So we go again. We can transfer this, do a little translation. I can write that minus 6L is 16 minus what? Minus 84. 16 minus 84. That's what we have here. Because 6 times this will give us 84. 6 times this will give us 6L. Now we have this and this are like, and when this moves to that side, we're going to have what? We're going to have minus 84. So we have minus 6L plus 16 minus 84 will give me minus 68. That's what we're going to have. Minus 68. That's what we're going to have there. And that will now give me L to be equal to minus 68 over minus 6. When we divide that, we're going to have L equals, when 6 divide this, is going to be 1. Dividing this will give us 1 again. Into 20 will give us what? 3, remaining 2. Into 20 again, 3, remaining 2. Then we have that, and leave it in 2 decimal places. 11.33 cm. 11.33 cm. Now let me say this. You will notice that I have 14 cm and I have 4 cm. Someone will be wondering, why didn't you change the length to meter? Even if I change this to meter and also change this to meter, I will still be arriving at this. Yes, I will say, but you can still change it to have 0.14 and 0.04, and then you will still arrive at the same answer. You will arrive at the same answer. All right. I believe that so far, so good. We're going to take a break. When we return, we are going to continue with our calculations. We just solved one problem from WASI. We're going to take another problem from JAMB or NICO when we return. Don't go too far. Continue to enjoy our classes, especially these revision classes, because it will help you to prepare for your exam, so that you will not be a failure, so that you will not start moving up and down looking for who to pay to write exams for you. All these exams are simple. If only you will calm down and just concentrate on your books, then you will see yourself doing marvelously well in this exam. All right, I'm going for a short break, and when we return, we will now look at other questions as it concerns what? Elasticity of materials. Thank you.